Right. A very interesting question. So here we have two right triangles. I think you can see those two. And few lengths. We want to compute these QS, QP, and QT, those lengths. So I wrote given lengths here. These lengths separately, I wrote those lengths. So what's the approach? What's the method to determine these lengths? Right? Observe carefully these two triangles. I would like to focus on uh, the angles actually, right? So for that, we need a better diagram, I think. Yeah, as you can see, here we have two triangles, definitely. QST, that's the smaller one, and the bigger one. Let me draw that triangle separately here, QST. But more importantly, that's a right triangle. Therefore, that's important. So that is the smaller triangle and the bigger one, that is QPR. So, like this. So these two triangles basically, right? Now, what can you say about angles? Angles of these two triangles. Here, would you believe that this angle one can write that angle as PQR using the bigger triangle, or using the smaller triangle SQT. Doesn't really matter what's the triangle that you use, the angle is same. That's the bottom line. So PQR equals to SQT. In other words, that angle is common for both triangles. So I can mark that angle on these two triangles. This one and this one. Same triangle, same angle. Like this. Same angle. Then 90-degree angle. Here we have a 90-degree here on the bigger triangle. That is PRQ. If you are using the bigger triangle, that's PRQ. And this one, QST, same, because 90 degrees. So those two angles also equal. Now let's suppose just a random value. I'm going to put a random value for this yellow colored angle, like 40. Then what can you say about these angles? First of all, this one. QPR. Now I think that should equals to what? Here 40, 90 here. Sum of interior angles definitely equals to 180. Therefore, this one equals to 180 minus 40 plus 90. Which is 180 minus 130. That is 50 degrees. Just a random value, right? So random value, 40 degrees. But I use the same value to explain the concept. So therefore, no worries. Similarly, compute this one. Again, 180 degrees. Sum of interior angles of a triangle. Same calculation gives us the same angle. that is 50 degrees. So in other words, these two angles equals to each other. So what happened? All three angles equal separately. Here, these two and these two, and also 90 degrees. But are these two triangles equal? Are these two triangles same? We don't know that. Probably not. Actually, that can't happen because one triangle is clearly bigger than the other. PQR is bigger than the smaller triangle SQT. Then what's the meaning of these angles? So these angles equals to each other. What's the meaning of that? Which means actually this PQR triangle is a magnified version of SQT. You can create that PQR triangle from that SQT triangle by multiplying that triangle by a certain value. For example, we don't know that. It could be 3. Why? We don't know. Multiply each length by that value, you will get the bigger triangle. We use a special name for that as well, scale factor. Okay, don't need to worry too much about that term. Just a magnified version. In other words, and also you can create the smaller triangle from the bigger one, right? Can minimize that. Okay. Now, then focus on corresponding sides. Now, these angles are very, very important. So, A, three angles, angle, similarity. Because we found all three angles are same for both triangles. Now focus on these angles. For example, let me start with that yellow colored angle. Then the opposite side, opposite length is PR, and opposite length of, okay, let me use yellow. That's the opposite length of this yellow colored angle. Then similarly, for the other triangle, for the next triangle, you can draw arrow like this again. Then those two sides corresponding, PR and ST, which means there is a relationship between PR and ST. I mentioned about multiplying a triangle by a certain value. So PR, to get PR, you should multiply ST by a certain value. I think that's very obvious because PR is the bigger length, ST is small. Multiply by a certain value like this. That's the idea. Similarly, pick another length, like another angle, like blue angle. Then the opposite side and opposite side. Again, the same idea. QR equals to QS. Yeah, that side, I think you can see. These two sides are corresponding. That's why I mentioned about angles. Angles are very, very important. We use angles to determine the corresponding side. because you can't multiply whatever the side you want. We multiply corresponding sides. We consider corresponding sides. So there is a relationship between QR and QS because those sides are corresponding. So to get QR, we should multiply QS by the same value. We multiplied initially ST by that value to get PR. We use same value. See, the same value. That's the beauty of this. Use the same value. That's the scale factor, in other words, right? Then the 90 degree angle, again the opposite sides, right? 90 degrees opposite side. Then here 90 degrees opposite side. Again write the relationship. QP, QT. So we can write QP equals to, that's the bigger length, equals to what? QT, that's the smaller length, times that exact same value. Here, these three values are not different, distinct values. These three values are same basically. Now I need this value. Right? That's the most important part. Writing these relationships. Then you can compute that value. That's the scale factor. That's the number we need because we want to multiply the smaller triangle by this value to get the bigger triangle. You can't multiply a triangle, right? You only allow to multiply length, sides of triangle. That's exactly what we are doing. So now we can use these lengths, PR, ST, and QR. PR equals to 8 feet, ST3, QR, ST 3 feet, sorry, PR 6 feet, QR 8 feet. Now substitute those values. Let's try to determine that value, right? Yeah, that's the idea. Let me put a letter for that. Let's say K or something. We need that value, K, right? So what's the most suitable equation? I think clearly the first one, because we have PR and ST. It depends upon the question, right? For some questions, you might have different lengths, then you should use that. But should be able to write these three. That's the most important part. That's the fundamental. Then let me replace PR by 6 and ST by 3 times K. Now what's the K value? Let me divide both sides by 3 to get K. That's the scale factor, equals to 2. Now we know that magical value, that is 2. Basically, we have to multiply each length of this small triangle by 2 to get the bigger one. Now that's it, I think. Then, so K equals to 2. Let's focus on the second equation. Because we have QR. So QR equals QS times K. But K equals to 2 and QR equals to 8. Yeah, that's a given length. Hence, we can compute QS. Divide both sides by 2. And also that's very obvious because to get 8, you have to multiply 4 by 2 because we found the scale factor. So QS equals to 4. Right. But you can't use the next equation to determine those lengths because we don't have both of these lengths. Can you understand? So QP equals to QT times K, and we found K, that is 2. But we have 2 unknowns and 1 equation. Can't compute, right? So what are your thoughts on that? Right? You can name few possible cases, few possible values. When QT equals to 5, QP equals to 10, or when QT equals to 11, QP equals to 22, but so many possibilities, right? So this equation is not sufficient. So we need another equation. I'm going to explain that. But writing these relationships using scale factor is quite important when you are solving these questions. That's the most important part. The conclusion is identify triangles, similar triangles, identify angles, then write these relationships properly, then you will be able to compute, right? To write these relationships, we used angles. That's the only way to determine corresponding sides. You can't use whatever the side you want. You should focus on angles. Therefore, starts with those angles. Determine corresponding angles. Yeah. We can continue this problem. We need another relationship. I will explain that in the next session. Thank you very much.